You know, when you think of a turtle, you probably picture that shell, right? A simple, sturdy dome. But it turns out it's one of the most complex and, frankly, brilliant designs in all of nature. This isn't just a piece of armor somebody put on. It's a story of biological engineering and evolutionary genius, and we're about to unpack how it all works.
So, let me start with a quick question. How many pieces do you think make up a turtle's shell? Is it one solid piece? Maybe two? A top and a bottom? Well, get this. It's actually a living fortress, a complex mosaic of about 60 different bones, and they are fused directly into the turtle's own skeleton.
And that's the real mystery here, isn't it? I mean, it's one thing to have a skeleton inside your body. It is something else entirely to rebuild it into an impenetrable box that you live inside. So, how on earth did the turtle pull this off?
To figure that out, we first need to get a look at the blueprints. This isn't just some simple dome. It's a marvel of natural construction, with different parts that do very specific jobs.
You see, the shell isn't one solid piece. It's actually a two-part system that develops separately before it all fuses together. The top dome, that's the carapace. It's formed from about 50 bones, and that includes the turtle's own ribs and its backbone. And then the bottom part is the plastron, which is a set of 9 bony plates shielding the belly. The entire fortress is literally built from the inside out.
Okay, so we know what it's made of. But how does a modern turtle actually build this thing? Well, the process starts when it's just a tiny embryo, and it's a developmental journey that's unlike almost any other animal on the planet. All right, here's the secret ingredient. It's called the carapacial ridge. Early on, a turtle embryo looks pretty similar to a bird's or even a mammal's. But then, this unique bulge of cells appears along its back. And this ridge, it acts like the master architect, basically telling the embryo, okay, we're not doing it like everyone else, we're building a shell. So instead of growing down to form a typical rib cage like ours, the turtle's ribs are actually drawn outwards, towards that carapacial ridge. And as they spread out, they start releasing a special protein that tells all the surrounding tissue, hey, you, turn into bone. And those 50 or so bones just keep expanding until they fuse together with these tough, fibrous joints, creating that solid top shell.
So you've basically got two totally different construction crews working on the same project. The top shell, the carapace, that's built by the ribs following the architect's blueprint. But the belly plate, the plastron, that's formed by a completely different group of superversita cells that literally migrate across the embryo's belly. Think of them like mobile construction workers who just assemble the 9 bony plates from scratch. Two different paths, one incredible structure.
So, okay, that's how it happens today. But that's only half the story. The real question is, how on earth did this whole bizarre process even get started in the first place? For that, we have to travel way back in time, deep into the fossil record.
And this is where the story takes a really unexpected turn. The very first change that led to the shell, it probably had nothing to do with protection. All the evidence suggests the turtle's ancestors first broadened the ribs to become super powerful burrowers. The armor, that came later.
This whole journey took millions of years. It kicked off 260 million years ago with a creature called Unitorosaurus. This guy had these wide, flat ribs, but they were for anchoring big digging muscles. Then, later, along comes Odontochelys. It kept those broad ribs, but added a bony belly plate for protection in the water. It was half-shelled. And finally, by 210 million years ago, Progonochelys shows up in the fossil record, the first creature we know of with a complete, fully fused shell.
And Progonochelys was something else. It had the full shell we'd recognize today and lived on both land and in water. But here's the thing. It couldn't pull its head into its shell for safety. So instead, it had to rely on these gnarly defensive spines on its neck to keep predators away. A little more punk rock than your modern tortoise for sure.
So having a shell is obviously a huge advantage for protection. But, living your whole life inside a rigid, bony box, that comes with some serious biological challenges. You can't just change your entire body plan without a few consequences.
And here is the biggest one. I mean, think about it. Just take a deep breath right now. Feel your ribcage expand and contract. Yeah, a turtle can't do that. Their ribs are fused into a solid, immovable shell. So, how do you get air in and out?
The turtle's solution is just brilliant. Since they can't use their ribs, they evolved a special set of abdominal muscles. One muscle pulls all their internal organs inward, which creates a vacuum and sucks air into the lungs, and then another muscle pushes those organs back out, forcing the air out. They essentially use their guts as a giant diaphragm. It is a truly remarkable workaround. So once they nailed this design, a solid shell plus this weird breathing system, it was a total game changer. It was so effective that it became the foundation for this incredible diversity. Over millions of years, turtles adapted this basic model for all kinds of different lifestyles.
You've got sea turtles, for example. They evolved flatter, lighter shells to be more streamlined for gliding through the water. Land tortoises, on the other hand, developed these high, domed shells that are super hard for predators to crush, and they also help them get back on their feet if they flip over. And then there are soft-shell turtles, who traded bony plates for a flexible, leathery shell that's perfect for squeezing into tight spaces.
And that's really the heart of the story, isn't it? The turtle's shell is this powerful lesson in evolution. It didn't just invent armor from scratch. It took what it already had, ribs, vertebrae, skin, and just repurposed it, re-engineered it, and transformed it all into one of the most effective defensive structures in the entire animal kingdom.
So the next time you see a turtle, I hope you remember the incredible story locked inside that shell, a story of development, adaptation, and sheer survival. And it makes you wonder, right? What other animals that we see every day are hiding an equally complex and surprising history, just waiting to be discovered?